Okay. The whole packet being these two documents, or are there more?
No, I said like 5 or 6 other ones.
Okay. The solution for this is the circled answers are the correct ones?
Yeah.
Okay. Is there a particular, I know how to do this algebraically. Is there a particular reason they're showing us the charts, or?
I don't think it matters how you do it.
All right. Let's talk about doing it algebraically.
All right.
All right. Absolute value of 4 minus x plus 1 is greater than or equal to the absolute value of 2x. Okay, to do these, you want to use this principle. The absolute value of x is greater than or equal to 3 means what?
What does it mean?
Huh?
That absolute value of x is greater
Means
than
that
or equal to 3.
it means that either x is greater than or equal to 3, or it means x is less than or equal to minus 3. In other words, whenever you solve an inequality containing an absolute value, that's what you have to do. And if it's complicated inside, like x minus 2, then you say x minus 2 is greater than or equal to 3, or x minus 2 is less than or equal to negative 3. In other words, the other side of the or is you switch directions and you change the sign. But notice one thing you never do is change what's inside the absolute values. Okay? All right. So, this is easy. This is more complicated because we have two absolute values. So, we have to isolate one of them. Well, probably the easier one to isolate is this one here. So, let's rewrite this as the absolute value of 2x is less than or equals the absolute value of 4 minus x plus 1. You're with me so far?
Okay.
Okay? Now, what does this mean? Okay, it means that 2x is less than or equal to the absolute value of 4 minus x plus 1, or what?
2x is greater than or equal to negative 4.
The negative of that whole thing. Let's just for the moment state the negative of the whole thing like the following here. Okay. Now we solve each one. Normally when you have an absolute value in an inequality, you get two answers. But when you have two absolute values, like we do here in an inequality, you have to solve each one separately. Well, this alone is going to give us two answers, and this alone is going to give us two answers. So we might get four answers. Some of them might be the same, but that's the way we're going to proceed. In other words, you eliminate one absolute value sign per step. Notice that we now have two inequalities that we can solve rather easily because each one of them only has one absolute value in it. So let's start on this one here. So what does this mean? Let's rewrite it so that we isolate the absolute value and we put it on the left.
If you want to put on the left, then it could be absolute value of 4 minus x is less than or equal to negative 2x plus 1.
Well, I'm going to switch it if I'm going to put it on the left. Notice that this is greater than or equal to 2x. So I'm putting it on the left only because I'm more comfortable with having my absolute values on the left. Okay?
Okay.
This means two things. What's the first thing?
That it's greater, or no, it's that 4 minus x is greater than or equal to 2x minus 1.
Or
that it's less than or equal to negative, and then like negative, and then in parentheses 2x minus 1.
so that would be negative 2x plus 1, right?
Yeah.
Okay, now let's solve for x. Well, we can solve for x here. What do I have to do?
Add the x from the left side to the right side, so you get 4.
So we get 3x over there. I'm going to move this 1 to the other side, so I get 5. So we got x is less than or equal to 5/3. Let's put the x on the left, reverse the sign. Oops, hold on. No, I didn't mean to do that. I didn't reverse the sign. Okay. All right, so there's one solution.
Okay.
Now, let's solve this one.
You have 4 minus x is less than or equal to negative 2x plus 1, or 4 minus x is greater than or equal to 2x plus 1.
No, you can't just change one negative sign. Got to change it both. And first of all, we don't need to do that. Let's work with this right like it is. And let's add 2x to both sides so that we're going to end up with x over here.
All right.
And I'm only adding. Whenever you're adding or subtracting, you don't change the sign. It's only when you're multiplying or dividing by a negative. So now I have to move the 4 over to the other side, becomes minus 3. So there is one other solution. Now, we need to deal with this part here.
Okay.
Okay? And this is the way you have to do these. These are fairly hard. Let me just write this here so I have a little room to write. They're not hard, they're just tedious. Once you memorize the method, then everything else is just pretty easy. It's the method that's tough. Okay, so first of all, let's get rid of this negative sign in front of the everything. How about we divide by negative 1? So we have minus 2x. When I'm dividing by negative 1, I have to subtract. With me?
Yeah.
Okay. Now I want to get this all by itself, so let's put it on the left. I'm more comfortable working that way with absolute values. Reverse the sign. Minus 2x minus 1. Still with me?
Okay. Yep.
So what does this mean?
4 minus x is greater than or equal to negative 2x minus 1. Or that it is less than or equal to 2x plus 1, or to just be 2x minus 1.
Be 2x plus 1. In other words, we've got to change the sign on everything that's on the other side of that inequality.
Okay.
All right. Now we solve this one here and then this one separately, and that's going to give us all of our solutions. What's the best way to solve this?
Add the 2x so it becomes x is greater than or equal to -5. Yeah.
And then solve this one. With inequalities, go ahead.
Subtract 2x, so you get -3x is less than or equal to -3.
Which makes
-1 or 1.
what -1?
Oh, greater than or equal to -1.
It's greater than or equal to 1. In other words, I have to divide both sides by -3. That turns this side into a +1, but I have to switch the sign.
Okay.
So here's all of our solutions. Let's find an answer that reflects that. Wow, I don't like what I'm looking at here. Let's see, what do we have? X has to be less than or equal to 5/3, and it has to be less than or equal to 3. So this kind of rules. And here it has to be greater than or equal to 1. There's no way A or B could be the answer because they're in terms of y, not x. Less than or equal to -5 or greater than or equal to 5/3. Almost looks like, let's see, right here, D is the answer. Notice that D is my extremes. D is greater than or equal to the lowest number, -5, and less than or equal to the highest number, 5/3, on the number line.
Okay.
And that's why you can take all 4 of these solutions and combine them into one solution like that, because you just want to use your extreme points only. That's the only way I know how to solve those. If that's the way they taught you,
Okay.
I hope so, but I don't know another way. I figured out that way kind of on my own. But this way works pretty good. In other words, you isolate one absolute value, create 2 more inequalities, and then you can isolate each absolute value separately.
Okay.
All right. Number 2. Is number 2 any different than 1? Yeah, it's got everything on the other side. So the question is, can we save ourselves any effort here? It would appear so. Notice that the only difference between, I'm not sure what good this does you, because you're never going to get this on a test, I wouldn't think. But notice the only difference here is they've put the absolute value of 2x on the other side and all of this on the right side. And notice that the correct answer is the exact opposite. It's x is less than that and x is greater than that.
Yeah.
So, you want to go through it or you want to go on to number 3? We got 6 pages to cover, and we're going to have how many sessions? 2 hours before your test?
I think don't we have one today, tomorrow, and then, what, Monday or Tuesday?
Maybe we do. I didn't. Let's see. We have one today. We have one tomorrow. We don't have one Monday, but we do have one Tuesday. and in an emergency we could try to squeeze you in on Monday. Although it's going to be a tough squeeze in, I could still pull it off. So we'll see how it goes as to whether we have 3 sessions or maybe 3.5. So
Okay.
I don't know how many total questions there are, but it seems to me that if you get how to do this, you're going to know how to do this. Just work through all 4 steps, you'll get this answer. It's an interesting sidelight that they switch everything and it comes up with the exact opposite answer. Not sure how useful that is to you, but it appears to be true. In other words, if you knew that, you could save yourself 10 minutes worth of work on question number 2, if he indeed gives you a question number 1 and a question number 2. Now,
Yeah.
notice that we could solve this graphically.
Mm-hmm.
In that this is the 2x, this is the 4 minus x plus 1. The solution we came up with, these are the 2 points, I believe, yeah, minus 5 and 5/3. So if you can shade both of these properly, you can come up with the solution by the intersection points and knowing which side to be on that shade.
Okay.
Okay. Tell you what, let's go to 3, and then if we have extra time, we'll come back and do 2, if you want.
All right.
I think that might be the best way to proceed here. We definitely want to make sure we cover everything that you're looking at. In general, I do like this technique of giving you a difficult problem and then giving you another one very similar to it. But I think you got that first one. We don't really need to check that. Okay. Okay, so y sub 1 is a horizontal line, right?
Yeah.
In fact, y sub 1 looks like it equals 8.
Okay.
Y sub 2 is a slanted line. What's the equation for y sub 2? What's the intercept?
The intercepts are at 2, 8, and negative 4.
Hold on. I'm looking at just this line right here, and I only want the y-intercept right there.
Oh.
So it's 2. We're going to put it in y equal mx plus b format. So what's the slope? Up 3 over 2?
I think so.
Yeah. In other words, I'm looking at the grid only. I don't care if they're 2 each. I know, it does matter. Excuse me. We're going from 2 to 8. That's up 6 over 2. That's a slope of 3. I almost made the mistake of looking at it visually, and each one of these squares is not 1 by 1. It's 1 on the x-axis, 2 on the y-axis.
Yeah.
So it really is up 6 over 2. So that's the equation for y sub 2. What's the equation for y sub 3?
Negative 10.
All right. So the solution. How can I write an inequality that states that right there?
8 is less than or equal to 3x plus 2. And then that is less than or equal to negative 10.
And now the key is to solve that. And solve this as two different equations. Solve it as that, and then solve it as that.
Yeah,
so
now this is
solve
starting
the
to come
left
back to me.
one. Solve the left one first.
You get 6 is less than or equal to 3x, so divide both sides by 3, you get 2 is less than or equal to x.
Okay. Now solve this one.
3x is greater than or less than or equal to negative 12. Divide by 3, you get x is less than or equal to negative 4.
So those are our answers. Which one says that? Oh, they're clever here. They didn't put it. No solution? Ah. Why is B not the answer? Seems to me that B is the answer. B is exactly what we came up with. We came up with x is greater than or equal to 2, and we came up with x is less than or equal to minus 4, which is exactly what B says. And if we plug in, well, let's see. So in other words, if I plug in a number like 1, yeah, in fact, it's even one block on the number line. It's everything from 2 to negative 4. So I'm saying that any number in that range satisfies that inequality.
Yeah, it says on her website answer sheet that it is D.
It's B?
D. D for dog.
Well, see if you can get her to explain that to you.
All right.
We'll have a few sessions before we're done with this. I don't get it. It seems to me the way I laid it out was exactly right. And notice that, say, x is 0. Doesn't work. What the heck? I must have made a mistake in the math. Hold on. I plug in x of 0, and obviously 2 is not greater than 8. So we made a mistake in the math here. What did we do? We said 3x is greater than...
No, I think it is D.
Yeah, but the question is why? In other words, x obviously has to be greater than 2. But then when you solve this, you get conflicting things. In other words, when you get a conflicting answer, x cannot be greater than or equal to 2 and also at the same time be less than or equal to minus 4.
Yeah.
That's an impossible solution. Now I get it. I was kind of thinking in interval notation, where you could have two different intervals as the solution. But the only solutions obviously has to be the solutions that overlap. In other words, all x's less than minus 4 make this true, but no x's less than minus 4 make this true. So the only solutions have to be the overlapping solutions. And that's why D is correct. Okay. Well, I learned something there myself. I didn't know that.
Number 4 is the exact same thing as 1 and 2. It's the same exact problem, just flipped.
Yeah.
And look, 3 is no solution and 4 is all real numbers.
Yeah. In other words, I would just take that exact same equation, or inequality rather, and I would flip the signs so that I erased all, no. So I would go to here and flip these two signs. And Now, when you solve it, you're going to get x is less than or equal to 2. And on the other side, you're going to get x is greater than or equal to minus 4. You're learning a lot about inequalities here. How does that translate into all real numbers? It seems to me like only this range here satisfies it. If x is 100, it's obviously not less than 8. I think answer is A on this one. It's not exactly the same thing. Oh, yes, it is. That does say exactly the same thing, doesn't it? It says y1 is greater than y2. Ah, notice the difference.
Yeah, there's an
There's
or.
a difference. This or makes all the difference in the world. This meant and. This means or. This is not the exact reverse of this.
Yeah, I just caught that.
And if you solve each one individually, I think you probably end up with all real numbers, although I don't quite see it. I guess in the first case you end up with x is greater than, or x is greater than 2. In the next case you end up with x is greater than minus 4. Still don't see how that is all real numbers. I don't want to belabor this any more than we are, but so we've got 8 is greater than or equal to 3x plus 2, or 3x plus 2 is greater than or equal to minus 10. It's all real numbers because x is less than or equal to 6, which covers all the numbers from negative infinity to 6. And this one is x is greater than or equal to minus 4, which covers all the numbers from minus 4 to positive infinity. Between the two, all real numbers.
Mm-hmm. Okay.
All right. Notice that the difference between this one and this one is this and right here.
Yeah.
So, let's see. That means that 8 is less than or equal to 3x plus 2, and 3x plus 2 is greater than negative 10. Right?
Yep.
Whereas this is kind of a combination. It's one is less than and the other is greater than, and we have an and instead of an or. So if we solve each one, we get x greater than or equal to 2 and x greater than or equal to minus 4. If both of those have to be true, and that's what the and means, then x has to be greater than 2.
Okay.
Because if x were, say, minus 3, this one would be true, but this one would not. If x were 5, this one is true, and this one is true.
Okay.
It's pretty cool. They're teaching you the difference between the and the or, which is not, I don't run into that very frequently. All right, I need the next page.
Yeah.
Got it. Half my difficulty here is setting up my whiteboard so I can write on it. Okay, how are we going to go about this one?
W equals, or no, L equals W minus 5. And then by doubling the length and increasing the width by 10. So then doubling the length and increasing the width by 10, you'd get 2W.
Hold it, doubling the length, 2L.
Yeah. Well, yeah, then that'd turn into 2W minus 5.
And that would have to equal that. Because if it's a square, the length equals the width. So we're increasing the width by 10, so we can say that. Now what?
If the length is doubled, it would turn into 2W minus 10 equals then the width plus 10.
In other words, by substitution.
Yeah.
What did I do wrong? Okay, here's what I did wrong. I didn't define my variables. L equals width, L equals length, W equals width. Okay? So if I can form a square by doubling the length and increasing the width, that means that. Now I substitute. In other words, the mistake I made was doubling this and then adding 10 to this. Well, you don't add 10 to this, you add 10 to W.
Yeah.
So now I get 2W minus 10 equals W plus 10. And I don't need to solve for W. The answers aren't solved. They're in terms of equations.
All right.
All right. That's a little tricky. It's easy to make that mistake I made. You want to send me another one?
I already did.
My goodness, a whole bunch of them, huh? Good. We can never have too much material to go over. Let me close that out. All right. moment you see a problem like this, what's the master equation? You're looking at a word problem that has speed, distances.
Distance equals rate times height.
Yeah, distance
height
equals,
times, sorry.
right, D equals RT. There's your master equation. And that's what's going to determine all of these other equations. Okay, so whose rates differ by 12 miles per hour, that means their velocities differ.
Yeah.
And they're 500 miles apart. And if they meet, determine the rate of the slower train. Okay, so we have train, let's call it train A here, train B here. This distance is 500 miles. Train A is going to go that way, train B is going to go that way. We'll call the rate of train A rate 1. We'll call the rate of train B rate 1 plus 12.
Okay.
Okay? So the time difference they've given us from 11 a.m. to 3:15 p.m. is how much?
Is 4.25 hours.
So in 4.25 hours, they meet, obviously, somewhere to the left of the center line. Right there, because this train's going faster. So what can I say? Let's write two equations. The distance that the slower train goes, which is A, is, we'll call it D. It's equal to its rate, rates of 1, times its time, 4.25.
Okay.
The distance that train B goes, not the same distance. We'll call this distance 1. This will be distance 2.
Is equal to R1 plus 12 times 4.25.
Actually, yes, okay. And one last equation is what? To incorporate the 500.
You'd add the two equations together and set them equal to 500. Yeah.
Okay. So, let's add this equation plus this equation and let it equal 500. What do we get? We get 4.25R equal plus, what was this again? 4.25R plus 51 equals 500. Is that on there anywhere? Yeah, right here. Hold on. No, right here. There's the 4.25R. There's the 4.25R plus 51. Okay. In other words, it was really R plus 12. It was really this.
Okay.
Okay. Those problems can be tricky. The secret of these train problems is, first of all, knowing that D equals RT, and then second, kind of laying out everything that you know. Lay out all the equations that you know, and keep your variables to a minimum. I don't know, just like that problem there, I guess. All right.
Okay.
Piggy bank problems. I love them. Okay, let's start with what?
Defining your variables.
Okay, so we're going to have D equals the number of dimes, N equal the number of nickels, and Q equal the number of quarters. So now start giving me some equations.
Actually, hold on. For variables, for number of dimes, it would actually be 2Q.
Why is that?
If you look in the problem, he has 2 times more dimes than quarters.
Well, that's going to
2Q.
give us our equations. In other words, we just defined our variables, that's all.
Oh, okay.
And the only reason I defined them is because it's important to know that there's a difference. D is not equal to the value of the dimes. D is equal to the number of dimes you have.
Okay.
N is equal to the number of nickels, and Q is the number of quarters. So one equation is he has 2 times more dimes than quarters. So dimes is equal to 2Q.
Okay.
He has 15 fewer quarters than nickels. What does that mean?
15 fewer quarters. So
16,
Q equals N minus 15?
16, excuse me, yes.
Or 16?
N minus 16. I realized when I looked at these answers I had misspoke. Okay, now the key equation is how much money he has. This is a recurring coin problem, so you really need to figure out or learn how this is done. So if you got a pocket full of change and you got 12 bucks in change in your pocket, how'd you arrive at that?
You
Took the number of nickels you had and you did what? You multiplied it by 0.05.
So you just do N times 0.5?
0.05 times the number of nickels gives you the value of your nickels.
Okay.
Plus point what?
0.1 times 2Q.
No, times D. Let's lay it out as the original equation before we start substituting.
Okay. And then 0.25 times Q.
That's a key part. In other words, the value of coins is the value of the coin times the number of the coins. Okay? Now, how many quarters are in his bank? So we want to switch everything to Q. Well, I can certainly define N in terms of Q. So what can I write?
So are we substituting what?
We're trying to get a final equation completely in Q. So in other words, I want to take this equation and solve it for N and substitute what down there?
For N, you just do Q plus 16.
And then for D, we want to put in terms of Q.
2Q.
So now we have one equation and one variable. And let's see what matches. We know it's D. Let's see if that fits our answer. 0.05. I kind of like the way they put their answers. They don't really solve for Q. They get it this far, and then they say, don't waste any more time on this, go to the next problem.
Yeah, I think it's just, they just want us to have getting all this, it's set up in the equation down.
Oh, absolutely.
Solving is really not that hard.
this is the tough part. Once you get it to there, it's easy after that. They don't want to waste your time with solving simple single variable equations. But they do want to waste your time with setting them up, because setting them up is the difficulty. So I love that they're doing this. I haven't seen very many.
Let's skip 9. Let's skip 9 and go to 10.
Okay.
But I think that might be on a different sheet. Your slide.
I've got 10 on here.
Okay.
Yeah, I got 10.
Okay.
And we can go back to 9 if we need to at some later point in time. Okay.
Okay.
She loves that, but I digress.
Yep.
Okay, this is fairly straightforward.
Yeah.
Hold on, interesting. Why don't they tell us how many rubber penguins they sold? We know it's 16. In other words, they're telling us they sold 22 stuffed and 6 fewer rubber, so it's 22 stuffed and 16 rubber.
Yeah.
Okay. Stuffed penguins are $3.45 more than rubber penguins, and the sales for both total $7.04. So what's our variable?
We just did S for stuffed penguins and R for rubber penguins, but
Well, but this is our variable over here. Determine the price, X, of one rubber penguin. So X is the price of one rubber penguin. Now, what equation can I write? Based on the middle sentence.
stuffed penguins are 3.45 more than rubber penguins. You could do 22 times 3.45.
X plus
And then
3.45.
16 times X equals 704.
Uh-huh. And that's probably their answer. D. Notice that the only thing confusing at all about this problem is that our variables were not S and R. They told us that there were 22 and 16 with that sentence right there. So there was nothing variable about it. The only variable was the price. So always pick your variable from the last sentence. Well, not always, but in general. There are some pretty difficult word problems here where your variables are not the very last sentence, but you and I haven't come across those yet. All right, I need a new page here. There was one day where when I was working with your semi-classmate, she had a bunch of those problems that you didn't get the variable from the very final sentence. The variable you had to figure out different, and those are probably the hardest word problems.
Yeah.
And I was hoping we actually would have a chance to go over some of those. And we never have, because we've moved forward, but
This one I had a lot of trouble with.
all right. Now let's draw a picture.
That's a beautiful triangle.
Okay, so that's X, and that's X. And this is 1/4 x. Well, can A be right? In other words, this almost seems like it's a back-solving problem.
Yeah, I thought it was A at first, but...
Well, A can't be right because it's an isosceles triangle. Two of the sides have to be the same.
Yeah.
Hold on a second. Wow, I'm not sure I even understand this question. Determine the possible lengths of each leg if the base must be an integer and the perimeter is at least 46 centimeters and no more than 80. Guess that rules out A. Okay, so A would be, we can have 6, 7, or 8 as x. That's what that means. Well, could we have 6? No, because that would mean we couldn't even have 8. Because if we had 8, it would be 8, 8, and 2. That would give you a perimeter of 18, way too small.
Yeah.
B, if we choose the smallest number for x, that would be 24, 24, and 6. So that would be a perimeter of 54, which works. So 24 works. Does 28, you see what I'm doing here? We have to, in other words, they're saying, if this is the correct answer, they're saying x could be 24, x could be 28, or x could be 32.
Yep.
So I'm going through each one and just checking to see whether they indeed could be that. Well, we just proved that it could be 24.
That's the nice thing about multiple choices for math. If it's an equation, you can just keep plugging the numbers in that they give you until you find it that works.
Right. And we're going to find 24 works, we're going to find 28 works, we're even going to find 32 works. What we're going to find is that 36 doesn't work, because 36 gives us 81 as a perimeter. So B can't be the right answer. We can check C. All of these are going to work, but does that mean it's the right answer? We really kind of have to check D and make sure that one of these doesn't work. So we'll try 20, 20, and 5. That's 45. Too small. So we can rule out D. So only C has all three values that work.
Couldn't we have ruled out D right away because we knew that 36 didn't work?
Yes. You mean because we ruled it out for B?
Yeah.
Yes, you're right. I didn't think of that. You're absolutely right. And that's very helpful because this is basically a back-solving problem. And it looks like they got this algebraic solution over here, which I guess would also work. If we solve that, oh yeah. Did you write this?
Yeah.
Well, that actually gives you the solution. Notice.
I don't remember where I got that 9, though.
Well, it's 9/4 because we have an x, and we have a 1/4 x. So that's 2 1/4 x, which is 9/4.
Okay.
So when you solve this problem, you are going to get answers that are between 24 and 32, and 36 is going to be outside that range, so you can throw it out. All of these are going to be outside that range. So you don't have to do this by back solving. It definitely is a relatively easy inequality to solve.
Yeah.
It'll tell you that x has to be, the only difficulty in it is the math doesn't appear to be all that easy. In other words, this says x has to be greater than or equal to 4/9 times 46. Well, that's not that easy. That's, in other words, you got to convert that to a number using your calculator. And then you're going to get some number up here that's probably 35 or something like that. And then you'd be able to answer it immediately. So actually, this really is the quicker way to go. Back solving is going to be slow because we actually have to test almost every one of these numbers.
But there's a lot smaller margin for error when back solving.
Yeah, I agree. I agree. Okay.
That's what I do. If I can't get the equation on multiple choice, I just start plugging the answers in until I find it.
Well, I tell you what, remember that when you go to take your SATs and ACTs, because back solving is very useful there.
Isn't it on the SAT if you guess and then the answer is wrong, it takes points off? So are you supposed to leave the blankets and go back?
It does, but guessing is still worth doing, because from a probability point of view, your odds of guessing, even if you know no information, are the same as what they take off. So it doesn't really cost you. In other words, if you have 4 questions and you don't know how to do them and you guess, you will guess correctly on 1 out of those 4, and on the other 3 they'll penalize you the same amount that you got credit for. So it didn't really cost you anything to guess.
But on the ACT, they don't take off for wrong answers?
They don't take off as much, at least. It's definitely worth guessing on the ACT. One of them, it's even money guessing, and the other one, it's profitable. So, in other words, what you want to come away from that is it's always worth guessing. Because for one thing, almost every problem, you know something. You might be able to eliminate one of the answers.
Yes. Now, on the SAT, do they give you 4 options or 5, or does it vary?
I'm not sure. I think it's just 4, but they also have some grid questions where it's not multiple choice. You have to fill in the answer. The SAT.
Okay.
I'd say 10% of the test is grid on the math portion.
One of the kids on our football team got a 30 on his ACT.
Yeah, that's pretty good. That's getting up there in the high 90s. I think 32 is 99 percentile. So, yeah. Well, you should do well. When are you going to take yours?
I have no idea. I don't think until next school year, probably.
Are you a junior or sophomore?
No, I'm a sophomore.
Oh, you're a sophomore. Oh, okay. Yeah, you don't need to take them for a while. But, oh, yeah, you'll do really well. Your biggest difficulty is it's going to be so long since you had geometry that you're liable to have forgot your geometry. But
yeah,
we should review, definitely. And you'll want to focus on your geometry because you'll be fine with the algebra.
It seems like schools out west take the ACT more than the SAT, but back east it's way more SAT than ACT.
I graduated in Maryland, and I never took the ACT. I only took the SAT, even to come out to college at Mines. That's all Mines needed was the SAT, or wanted. So what is this easy problem doing with all of those others we just did?
This is supposed to be one where you only use a calculator as a 4-function serial box calculator.
Oh, okay.
So pretty much just the basics of solving equations like 7th grade math.
So give me the next line.
Negative 6x plus, or it would be 6 minus 6x plus 12.
Okay.
And then you could combine the 6 and the 12 and just take off 18 at once. So you could get negative 6, yeah, 24, and then x equals negative 4, or 6. Or not 4, no.
Negative 4 is right, yeah.
Yep.
Okay. Actually, why don't we end it there? We'll end it on 12. And I can remember the last document that I opened. Okay. Jackson, I will talk to you on tomorrow.
What time is tomorrow's meeting?
Same time, noon.
Okay.
All right?
All right.
Have a good one. Bye-bye.
You too. Thank you.
Mm-hmm.